All right. Hi everyone. This is Leetcode Weekly Contest 508. Given an integer array of nums and two integers k and mo, exactly k elements from nums. Independently choose one of the following. The current value. Add to the total sum or multiply by mo. Um, After applying each selected element, mo decreases by 1 regardless of which option was chosen. The maximum possible total sum. I feel like um let's see. You gotta just sort nums, right? After you sort them, you take the greatest k, and then so it's 9. After 9, you can multiply by 2, 18, and then you can plus 6 to this. 18 and 6 plus 2. Okay, so we have long answer is 0. Um, Sort all nums, and we use greater for int I. Answer is equal to k is for mo is here. Mo is 10 to the fifth, right? Multiply the element and add the result to the total sum. Okay. For int I is 0, I smaller than k, I plus plus. 2 times, 2 times 9. So it may become negative. So like over here it's 2 times 9 is 18. And then it becomes 1. Let's see, 962. Okay, it becomes 1, so 6. Uh, Choose addition. Okay. Um, Nums size. If I is, oh, I is smaller than k. If mo is greater than 0, answer plus equal to 1 long times mo times nums I, else, and then mo minus minus, else answer plus equal to nums I. Return answer. Okay, so it's just a simple greedy. 26, 43, and 4. Okay, accepted. Next problem. Filter occupied intervals. You're given a 2D integer array occupied intervals, so these are the intervals that are occupied. Additionally, you are given two integers free start and free end, which define a time interval during which you are free. The free interval starts at free start and ends at free end inclusive. Merge all occupied intervals that overlap or touch, then remove all integer points in the free interval from the merged occupied interval. Okay. These intervals may overlap. Overlap or touch. 10 to the 9, okay. Origins 1, 5. 3, 8 remains in 1, 2. Okay. First we got sort them. Vector, vector, int, final. It's the updated interval, right? So UPD. UPD is equal to uh, dot pushback. occupied interval 0. So first is at the very beginning. Okay, and then for int I is 1, I smaller than occupied interval dot size, I plus plus. If intersects, then we can just change the last element, otherwise we can push back. If upd dot back 1 is plus 1 is greater than or equal to occupied intervals I 0, upd dot back 1 is equal to max, upd dot back 1 occupied intervals I1. Otherwise, upd dot pushback occupied intervals I. Okay, so we merged them together already. Now we gotta remove the intervals which have free start and free ending them. Okay, so vector integer answer for auto b in upd. Let's see. If v0 is greater than free and inclusive, greater than free and, or v1 is less than free start, answer dot pushback v. Sort them. Return answer. Okay, else if v0 is less than or equal to free end, right? And then else if v1 is less than is greater than or equal to free start. It's less than or equal to, so free start is less than or equal to v0, and this answer that let's see, restart smaller than equal to v0, and v1 is less than or equal to free end. We can just continue. Enter dot pushback v0 min v1 and free end minus 1. v0 is free end. No, actually this is this. This should be max free end plus 1 v0 and v1. Yeah. Otherwise, enter dot pushback. It should be v0 min free start minus 1 and v1. 2, 6, 12, 12, 14, 1, 2. Wrong answer. Free start is 2 and free end is 2. Oh, I forgot this case. v0 smaller than free start and free end is less than v1. Then answer gets pushed back to 2 different intervals. So one is answer to pushback v0 restart minus 1. The other one is answer dot pushback free end plus 1 and v1. Okay. 1133. Okay, accepted. What's my ranking? 494. Okay, I'm actually doing okay right now. Let's go to the next problem. Maximum subarray sum after multiplier. Is this the same thing as the first problem? About integer array nums, and a positive integer k. You must choose exactly one subarray of nums and perform exactly one of the following operations. Multiply each number in the chosen subarray by k. Divide each number in the chosen subarray by k. Use the floor. Okay, and when negative, use a ceiling value. Return the maximum possible sum of a non-empty subarray in the resulting array. Let's see. You choose one subarray and perform one of the following operations. The sum. Okay. Maximum possible sum of a non-empty subarray in the resulting array. 10 to the 5. Um, mm, the large sum is -1, so the output is a -1. If, okay, if sort all nums, if nums dot back is greater than or equal to 0, then all we have to do is return 1 long times nums dot back times k. That'll be the maximum subarray. Oh wait, no, not necessarily. We need the maximum sum. So 7. So over here, the maximum sum is 7. So 7 times 2 is 14. So basically, we need the maximum sum of the subarray. Uh, what do we do here? We can use this seg tree. Uh, yeah, I have my seg tree here in my segment tree part 1. I think it's this one. Yeah, it's this one. Long one. Int max. Seg tree seg nums. Um, return. Okay. If seg dot query 0 and start at 0 and then it's query is 0 to n. Long max is equal to seg dot query 0 nums dot size dot sum. If max is greater than or equal to 0, return max times k, else return min element all nums divided by k. Up to dot sum dot seg 14 and 0. See. So we take the absolute value of this and we negate it. 0. Min element, oh, max. Max element, all num. And A2, return A2. Max, all num. If it's less than 0, we return this A2. And we don't need this check. Answer. So I missed one test case. Wait, a lot of wrong answers. Let's see. Oh, do we need a min too? So a minimum, is that it? If it's a minimum, -1, -3. Well, if it's like, let's say, um, 1 and -4. No, -4 divided by 2 would become -2. Multiply each number by x, divide each number by x. Subarray chosen for operation and subarray chosen for the sum may be different. Well, let's see. If it's always better to give the positive integers multiplier. Just k. 10 to the 5, 10 to the 5, 10 to the 5. Everything is in long log. Something with A2. Return max times k. Let's see. Our array is -1, -3, and say 2, -3, and 3, and -4. Okay. So, and k is equal to 2. So here we just multiply this by 2, and we get 6. Right? Yeah. Um, is there a better way? Say 1, 2 over here. Maximum sum is still 3, so the answer should be 6. or just 4, 3. Wait, if k is equal to 1, then there's just no change, right? Yeah, if k is equal to 1, there's no change. This value is 10, let's say. If all of these values are 10, when if we have this, let's say, well, like so many negative 10s and 10s together, then after you do this on this 5 and negative 5 later, same thing. But if this is use a ceiling value, so if this is negative 9, right, then we have 5 and 4, so we gain 1. But we just use all of them. Unless we make this 9 too. Then it's still 4, it's the same thing. So what's going wrong? We actually don't know what's wrong here. I'll try Q4 first. The graph is represented by a 2D integer array edges where edges I to ui, vi, ti indicates a directed edge from node ui to node vi takes ti to traverse. Power, cost. Two integer source and target. Okay. Follow the target. The signal may traverse directed edge and at least cost you. Node power is a consumer when consumer right side node unless it later leaves that node by traversing another edge. When the signal is forwarded from node U, the remaining power is decreased by cost U. Traversing increases total time, the minimum time, and the maximum remaining power. It's just some BFS, right? Nodes, vector in min time, and maximum remaining power. So time is 1u9, maximum remaining power. Then the time is the standard. Okay, we're going to use long ones. and then dp source uh time 0 and the remaining power is power q dot push n of source while not q dot empty int cur q dot front. Okay, q dot pop for int next in JSON. So we need to construct an adjacency list. TI, okay. Which is ABJ v dot 0 dot pushback. So it goes to v1 with time v2 and adjacent v1 dot pushback v0 v2. Okay. Uh, and v in adjacency current. Next is v0 added time, so at t is equal to v1 vector in long. Everything is long from now on. Target. Oh, if dp target equals to long max, return -1, -1, else there long none. Nope. So it's not possible. Nope. Now we'll see what this. Nope. Turn -1. Next vector. This should be dp current dp current 0 plus v0 and dp current 1. Well, it's add t minus cost current. Yeah, if cost current is greater than dp current 1, continue. Actually, this is the same for all of them, so we can just here continue. Okay. If next v0 is less than dp next 0 or next v0 is equal to dp next 0 and next v1 is greater than dp next 1 q dot push next and dp next is equal to next v. v0 0 3 and -1 -1. Answer or 3. Source target 0 1. Oh, it's directed. Okay, yeah, I forgot it was a directed graph. Uh, what answer for this? Oh, 103 0. Okay. I am doing horribly. Cost current greater than dp current. 1, 0 power. Is cost curve. Using edge increases total time by t seconds. The minimum time and the maximum remaining power that she answers 0. So minimum time, right? The answer should be 103 0. Minus cost curve. That takes ti seconds to traverse, and t is v1. Okay, yeah. Q dot push source. DP target goes nope, no return DP target. This seems correct. It starts at 0 power, and then next is DP current 0 plus add T, and DP current 1 minus cost curve. Versus time. Basically, we can still use one of our. We have min time at this place, and min time at this place, and the maximum power remaining. Wait, I think I'll try the others. Next. That doesn't seem to work. Oh, because I never called EFS. So it doesn't work for this word, actually. What if we do DFS 100 times? -1, -1. So is my Q solution better? Cost cur, dp cur 1, dp next is equal to next v, and DFS on next. Okay. Well, while we can do it, then we'll do it, right? Why is this not working? If cost cur is greater than dp cur 1, continue. So basically, we don't have enough power? Yeah, okay. Uh, Next be time, then power. And we have our target here. B0. Okay. If I can solve these two problems, then I think I should be okay, actually. Size of stack. So maximum segment. Okay. Who's the maximum segment? Yeah, okay, so um we choose the maximum segment, and then if we have the maximum segment, we can multiply that by k. Yeah, okay. I want to test something out. Oh, we can just do this. Yeah, okay. So, just like that. So basically, we can choose a subarray and we can either multiply by k or divide by k. Let's see. Uh, Give an example. For example, 2, -1. Actually, how about this? K is equal to 3. Give us to 2. And we have 1 and -1. Or 0 and -1. Uh, will we ever divide a thing by 2? Will we ever need to divide by 2? That's the question. Will we ever use a division? Well, okay, so we'll only use the division if they're all negative. All the elements are negative. What if we have something like, well, then this is 0 and then the sum is 2, but that's the same as this 2 over here. Okay, then sum is 2, 4, -1. Three and 3. What do we got 4 over here? Then the total sum is 4 equals 8, which is better than dividing these by 2. Find some possible sum of a non-empty subarray in the resulting array. So key thing is it's non-empty. Oh, what if seg is 0? So if we have a test case where we have 1, oh, 0, and k is 2, what do you get? You get 0. Uh, what is 0 is k is 1. 0, -1. Wait, -1 and -1 divided by 2 is, it's supposed to be 0, right? Yeah, it's 0, but if nums is -1 and k is 1, then we get -1. Oh, k is 1. That's why. K is 2. K is 2 and alpha 0. Okay, that's nums size is starting from 1. Subarray chosen for the operation and the subarray chosen for the sum may be different. Is that like a hint? Don't know what's wrong actually. For both problems. Power is 4. That's okay. Source, target is 1. 1 to 1. Three. It's just on 3. Hmm. Just one. 3. 1, 3. Well, that's 2. 1, 14. 13. 3, 13 is 31. So, 31. 13. 13, 11 is 20. Let's see. 12 to 1 is 26. Say we have, if you multiply, oh, you can multiply this into 4 and then it becomes 4. Alright, it's 4, 4, 4. 3 is 6. I feel like I'm feeling some like really small test case. R and 0 return max divided by k. That would be the smallest. Right? Not perfect at all. Oh, I can wrong answer. For greatest, if it's positive, then you choose to multiply it. So for the maximum summary, we choose to multiply all of its elements by k. Otherwise, if it's negative, we choose to divide it by k. Is that right? Yeah, that's what we do. For every, let's see, divide by 2. If we don't choose to divide this by 2, what good does it do us? Well, let's see this far. So right here, the maximum sum is 5, so we do 5 times 2 is 10. What do we do here? Negative 5, negative 3, so no, that's no good. Exactly 1 squared. Multiply each number in the chosen separated by k. Divide each number in the chosen separated by k. When dividing a positive number by k, use the floor value of the division result. When dividing a negative number by k, use the ceiling value of the division result. If we have this, so we have a maximum sum summary. So we have if we have our array of integers, If these are our array of integers, so this is our max segment. Well, can we like divide a subsegment of length k that has the minimum? Will that always, will that sometimes be good? For example, 4, -10, uh, um, 18, -20, and 4. So here the maximum sum is this, right? So is it sometimes good for the like 1, 2, 7, -18, 7, 10, -4. We have to do that or else -4. Here the maximum sum is 10, so it's 20. Or we could choose to divide these by 2. Well, here's the thing, the 10s cancel out. Yeah, the 10s cancel out. Can I try to hardcode this? Six hundred 636, 635. Okay. Why does it not show the test case that fields? Mhm. So, N is equal to 109, power equals to 440, and source is equal to 79, and target is equal to 75, return 14064. Okay, and if N is equal to 297, and power is equal to 434, and source is equal to 239, and target is equal to 284, return 4858933, 15. 97434 4858933, 15. No, it's hidden. Well, just have to try to solve it. After leaving node 0 to signals 2 units of power remaining is less than cost 1 is equal to 3. Signals forwarded from node U, the remaining parts decrease by cost U units. Traversing edge increases the total time by Ti seconds. Forward 4297. CPU curve 1 minus cost curve. PP next equals next P. So you start from the source, right? Yeah. Everything adjacent. Why does it not reach? Upward, lost, right, current, P. Oh well, I actually didn't go to so many, it didn't reach so many, like, vertices. It's because the cost is only 4. And reach 1. Three, 2, just a point. Just using the from array, so hopefully I can debug this out. 1 from 10, from 0 from 13. Wait, which one does it start from again? It starts from 3. Wait, how do I get from 13? What do I see? 13 to 1, 31, 3. 13. Sorry. So 13 must have gone to 0, and 0 went to 0 into 10. So we start at 3. From next into which occur. 1, 10, 0, 13, and um, oh, these are all the ticket. Get a pop. If cost curve greater than DP curve 1, continue. Okay, so it's not this. From and -1. DB source is 0 power. Q dot push source. There's Q dot front, Q dot pop. If cost curve is greater than DP curve 1, continue. Okay, so current, you gotta transfer from current to the other ones. xb squared and dp next 1. xb squared and dp next 1. So basically, if you have more power, okay. Supposed to be 103, 3, 13, 3, 13, 0, 10. All 1. The cost is all 1. 68, negative 1. Then we just get 68, 0 with power squared, and we just got 68, 0. So there must be something wrong. Um, over here, or over here. House current is greater than dp current. Continue. Right, because we can't do anything with it. dp current 0 plus at t, dp current 1 minus cost current. Why is this wrong though? I know it's a Leetcode medium, so it's probably not using sectree. My puke water. See this still down. See this still down. Well, I'm actually gonna stop it right here. Yeah, I'm actually gonna stop this recording right here, and I'm going to make some video editorials, and while doing it, I'll also query AI for the solutions to the final two problems.